All right, students, today we are on 6.5 and we are solving rational equations. So, first piece is what is rational? What does rational mean? And rational is a fraction, and I like to modify that as a fraction that ends. So, an irrational number is a number that goes on forever. A rational number has an end, like 1/2 is 0.5. 1/3 would not be rational. It's 0.33333. It goes on forever. So, all right, let's get right into it. Example number 1. What if I have 2 over x plus 8 equals 5 over 2x minus 7? Now, I'm going to show you two things. The first thing I'm going to show you is uh, excluded values. And excluded values are values that cannot work. And you know that a fraction, anything over 0, is not a real number. It's just not a number. It's not possible to have x zeros. It's not possible to have some number of 0. And so in a calculator, this would show up as error, right? Because it is not a number. And so if you ever get a 0 on the bottom, or if there's a number that will get you to 0 on the bottom, that's an excluded value. For example, what can x equal that would make this 0? Well, x plus 8, what would it to equal 0? So if x was negative 8, this would be 0. And we cannot have 0 on the bottom. So an excluded value, x cannot equal negative 8. So for this equation, x cannot equal negative 8. That's an excluded value. The other excluded value would be to get this denominator to equal to 0. So if I get this denominator equal to 0, I end up with standard algebra that you do. 7 over 2. 7 divided by 2 is 3.5. So 3.5, if I plug 3.5 into here, this would be 0. And I cannot have a 0 in the denominator. So my other excluded value is x cannot equal 3.5. So that's part of what we're doing today. This is just excluded values. So for this problem, x cannot equal negative 8 and x cannot equal 3.5. Now the second piece of what we're going to do today is we are going to solve for x with the same equation. Solve for x. And we talked about it yesterday, or maybe we did, maybe we didn't. How do you solve these fractions? Well, you do, some people say the butterfly, some people say cross multiply. I multiply these and I make it equal to this. So I multiply 5 times this. So 5 times x plus 8 equals 2 times this. 2 times 2x minus 7. So I get 5x plus 40 equals 4x minus 14. Right? So I just distributed this. 5 times x is 5x. 5 times 8 is 40. 2 times 2 is 2 times 2x is 4x. 2 times negative 7 is negative 14. And now I solve it like a normal algebra problem. Minus 4x. I get x plus 40 equals negative 14 minus 40 from both sides. And I get x equals negative 54. So solve for x. What does x equal? X equals negative 54. All right. Example number 2. Example number 2. I have x plus 1 over x minus 3 equals x plus 2 over x minus 6. Now, my first piece, what are my excluded values? What are the values that make this equal to 0? 3 minus 3 is 0. So x cannot equal 3. And right here, x, maybe my brain isn't quite up to speed because it's the morning. So x, 6. So x cannot equal 6 because 6 minus 6 is 0. So, and I cannot have a 0 in the denominator. 3 minus 3 is 0. I cannot have a denominator, 0 in the denominator. So those are my excluded values right there. Now I'm going to solve for x. How do I solve for x? I cross multiply. So I have x minus 3 times x plus 2. And that equals x plus 1 times x minus 6. Now the easiest way we've done this is we've done boxcar choral. I have x negative 3, and I have x 2. I have x squared negative 3x. Oops. 2x and negative 6. So I have x squared plus 2x minus 3x minus 6. I combine my two like terms, so I have x squared minus 1x minus 6. So this side is x squared minus 1x minus 6. And then let's take this one. Over for our boxcar trolls. And we've got x1 and x negative 6. So I have x squared negative 6x, 1x, and negative 6. So I have x squared minus 6x plus 1x minus 6. Combine my like terms. I get x squared minus 5x minus 6. So there, this goes on the other side of the equal sign. So I have x squared minus 5x minus 6. Now I solve it. Plus 6, x squared minus 1x equals x squared minus 5x. That's 0. 6, negative 6 plus 6 is 0. That's minus x squared minus x squared. No, x squared minus x squared is 0. So negative 1x equals negative 5x. Let's add 5x on both sides. Now here, be careful. Have 4x equals, it's not nothing, right? I have to put something on this side. If I have an equation, negative 5x plus 5x is 0. Divided by 4, x equals 0. Wait a second, Mr. Blue, there's a 0 in the numerator. That's right. A 0 in the numerator is okay, because you could have 0/4, you could have nothing. That's nothing, right? It's a 0 in the denominator that doesn't work, because you can't have 4 zeros. You can't have 4 of nothing. So our answer for example 2, x equals 0, because 0 divided by 4 is 0. All right. Check out example 3. We're combining a few things here. Not a few things, we're combining two things. So we have 3 over x plus 1 plus 4 over x plus 2 equals 15 over x plus 2. Now, if you notice, we have this little plus. So within our equation, we have a plus. So I can't just start by cross multiplying because we have an addition over here. Now the problem is we don't have like terms. So common denominators, excuse me. We don't have common denominators. So I got to multiply this side by x plus 2. And then this side I have to multiply by x plus 1. So what do I get? I get 3 times x plus 2 over x plus 2 times x plus 1 plus 4 times x plus 1 over x plus 2 times x plus 1. And this all equals 15 over x plus 2. So let's go ahead and distribute. So I'm going to distribute the 3. So I get 3x plus 6. 3x plus 6 over x plus 2 times x plus 1 plus 4x plus 4 over x plus 2 times x plus 1. Now let's add these. So I have my like terms. I have a 3x and a 4x. So I have 7x, 6 and a 4 plus 10 over, because these are my common denominators, x plus 2 times x plus 1 equals 15 over x plus 2. All right, now I have a number equals a number, or a fraction equals a fraction. So I can cross multiply. So I have 7x plus 10 times x plus 2 equals 15 times x plus 2 times x plus 1. Now, what I see here is I have an x plus 2 on this side and x plus 2 on this side. What if I just divide both sides by x plus 2 to get rid of it on this side and get rid of it on that side? Boom, boom. 7x plus 10 equals, and then I have 15 times x plus 1, so I distribute the 15 to the x and the 15 to the 1, so I get 15x plus 15. Now, let's solve it. Minus 7x. So 10 equals 8x plus 15. Minus 15. Negative 5 equals 8x. Divided by 8. So x equals negative 5/8. So there's the whole problem from top to bottom. Kind of blurry. There you go. Okay, that's example 3. We're going to do one more. We're going to do example number 4. And example number 4 is cool because we get a little bit of a shortcut in the end here. So check this out. I have 12 over x plus 4 minus 7 over x equals 22 over x squared plus 4x. So I've got a subtraction here. Will I help or hurt? All right. So this side, I have an x by itself here, x plus 4 here. So I'm going to have to actually multiply this side by an x and this side by an x plus 4. This side, x plus 4, x plus 4, So I now get 12x over x times x plus 4 minus 7x plus 28 over x times x plus 4 equals 22. And what I'm going to do here is I'm going to factor out an x. They both have an x in it. So I'm going to factor out an x. So x squared divided by x is x. 4x divided by x is 4. Look at x plus 4. X times x plus 4. X times x plus 4. When you have a common denominator on both sides of the equation, you can just ditch it. So now we have 12x minus 7x plus 28 equals 22. So I just got rid of the whole denominator because it's all the same. I just got rid of it. Oh, you might say, well, wait a second, what about the other ones? Well, the other ones we never had the same denominators. They were always different denominators. They're always different denominators. This one actually, the x plus 2 was the same on both sides. So actually I could have gotten rid of it here and just multiplied these because I had the same denominator on. I could have got rid of that earlier on. If I had the whole same denominator all the way across, I could just get rid of it. So now I'm left with this. Now don't forget, this is minus this whole thing. So I have to add the opposite. So I have to add a negative 7x, and then I have to add a negative 28. All right, 12x minus 7x is 5x. Minus 28 equals 22. Add 28. 5x equals 50. Divide by 5, and x equals 10. There you go. So that was your secret shortcut, was to be able to get rid of a denominator if it's all the same. So your homework is going to be page 192 to 193 in your student journal. And it's going to be numbers 1 through 12. 1 through 12. All right. Enjoy. If you have any questions, let me know.